All right, we're rolling straight into the end of Unit 1 here. We're in 1.1b, and specifically today we're talking about rational equations. These are going to look a little bit familiar, but they're going to have just a little bit of extra to do with them. It would help, before you do this today, to go back and review that factoring video, because that is going to play a role in some of the stuff that we do today. Rational equations, like I said, they look similar. They look similar to some of the linear equations in one variable that we had last time. You remember with something like this, we could multiply by 5, 2, and 15 to every denominator. 5, 2, 15. Here, 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 here. These are going to work very similarly, but the difference is, here's a regular linear equation with numbers in the denominator. Here's a rational equation. They have variables in the denominator. And so we do have to pay attention to that, because you remember there's one major rule in math, is that you can never divide by 0. And so with rational equations, there is the chance that x is something that makes the bottom 0, right? If we make the bottom 0, then we've broken a rule of math. And so we have to pay attention to that. A linear equation can be solved in the same way as a rational, where we're multiplying both sides by the least common denominator. In our case, we just said we're going to multiply by every different denominator. The same strategy applies to rational equations. I always say that the same strategy applies to any equation with fractions, right? We can clear those fractions at the beginning. The major first step, though, is to determine what x cannot be, because you don't want to get to the end to get a solution for x and think it's correct, but it's actually one of the restrictions of the equation. The way that you tell what x cannot be is it can't be anything that would eher make the bottom 0. It can't make the denominator 0. So in this case, if x was 0, that would make that denominator 0. If x was 0, that would make 2 times 0 be 0, right? So x cannot be 0 for this equation. X cannot be 0. That's the first step to any of these rational equations, is to figure out what x cannot be. Then we can go ahead and solve it the way that we were. So here's an example. The same exact example that I had just above. Knowing that x can't be 0, we can go ahead and solve it as normal. So we have an x and a 2x. That's the same as 2 times x. So if I multiply by x and 2, x and 2, x and 2, you're trying to get every different factor, right? So that the main thing is so that all of the denominators will go away. That's the key. So if I get rid of this x, if I get rid of that 2, if I get rid of that x, there's nothing on the bottom here to get rid of, right? So I can't get rid of anything there. But what we're left with, just like last class, is something totally without fractions. 2, 4, 24, 2 times 12. 6 has nothing left to multiply. Here we have 3 times x times 2 would be 6x. Now we can just solve it like a regular equation. So that would be 18 equals 6x, divide both sides by 6. 3 equals x. 3 is our solution, and you want to double check and make sure that that was not in your restrictions list. X can equal 3. The only thing it cannot equal is 0, so we have a solution here. You can go through and check this again on your calculator. You just sub in a 3 everywhere that there's an x in the original equation, and it should work out to where the left side is the same as the right side. All right, here we go. We've got y, and we've got 3 times y. So the two things that we need to multiply by, well, first, before we do that, we need to know our restrictions. What can y not equal? If y was equal to 0, then that bottom would go to 0. 3 times 0 would also be 0. So y cannot be 0. Y absolutely cannot be 0. If we get a 0 in the end, then we have to toss that answer out and just say that we have no solution, right? All right, now we've got a y and a 3 times y. That's the two different things in our denominators, 3 and y. They're not a single factor. The 3 and y are not a single factor because there's no plus or minus between them. If there was a plus or minus between them, like we'll see in a minute, we do have to treat them a little bit differently. But if I multiply by 3 and y, 3 and y, 3 and y, then eliminate the things that match up top to bottom. Remember, you're never touching the top here, right? You're never really fooling with the top. You're only eliminating what you just put there with what's below the fraction, the denominator of the fraction. All right, now let's multiply. 3 times 15 is 45. 21. 2 times 3 times y is 6y. We can subtract 21. We get 24 equals 6y. Divide both sides by 6. 4 equals y. We can go through and check it. It's important that it does not equal our restriction. So 4 is a valid solution. Again, you could plug it in up to that original equation and check it if you wanted to. We're just going to trust ourselves in this case. All right, here's an example of what I was talking about earlier, where this is one factor, okay? It's not x times 4, it's x minus 4, and so I have to treat it as its own thing. If there's a plus or a minus between them, you have to treat this as one item, the x minus 4 factor, or the x, if I had an x plus 7, for example, that would be an x plus 7 factor. So what the restrictions here are going to look a little bit different. It's the first one we have that the restriction is not just 0. We have to think what would make the bottom 0, aka what minus 4 would be 0. If x was 4, then we would have 4 minus 4, that would make the whole bottom 0. 4 minus 4, that would make the whole bottom 0. So x cannot equal 4. Look very carefully at that. If x was 4, the denominator of these would go to 0. Now, my only different factors on the bottom are 5 and x minus 4. So if I multiply everything by 5 and x minus 4, remember we're multiplying anything that's separated by a plus, a minus, or an equals. That should eliminate every denominator I have. So this x minus 4 factor gets rid of that one. This x minus 4 factor divides away with that one. That 5 will divide away there. I accidentally erased my 4 here. I did not mean to do that. All right, so this 5 eliminates with that 5 in the denominator. All right, and now we're going to multiply what's left. So 5 times x is 5x equals, I'm keeping the same signs as I had. 4 times 5 is 20. That's there. Keep the minus. This is really like a negative 4 here, okay? Negative 4 times this entire factor. Negative 4 times x is negative 4x. Negative 4 times negative 4 is positive 16. Now I'm just following the same steps that I followed in the last video where we want to combine like terms. So that would be 36 minus 4x. And we can add 4x and get 9x equals 36. Divide both sides by 9 and get x equals 4. That's a great solution. And we have a problem though. Do you guys see a problem here? The problem is that it matches up with your restriction. X cannot equal 4. We said that from the beginning. X can't equal 4. If it was 4, then it would make the denominator 0 up there. So we actually have to throw out that answer. And our answer is no solution, or our answer could look like this on Alex or MyLab. It could just be the empty set. There is no solution to this. There's no number that will make it correct. 4 seems like it will, but when I sub 4 in, if I try to sub it into the calculator, I'll get a domain error. It is important when you start a problem to note the numbers that x can't be, and when you finish a problem, to check and see if x is those answers. We're going to get to some of these later where we're dealing with quadratics, and we may end up with 2 answers and have to throw out one of them, right? We may end up with 3 answers and have to throw out one of them. Just whatever your restrictions are, you have to throw out that answer right there. If I ever get a 4 as a solution, you got to toss it out. All right, here's another one that's just like the one above. What I want you to do is, as always, take a second, try and solve it, and in about 3 seconds, I'm going to start unveiling things that I did. Pause the video. All right, the different denominators, the different factors are 4 and y plus 5. That's what I multiplied by on the top. And this is how I solve the equation right here. Once I multiply by 4 and y plus 5, the y plus 5 is divided away here, the y plus 5 is divided away here, the 4 is divided away here. Well, you get the point. This is what happened after I divided. My solution was y equals negative 5, and that turned out to be one of the restrictions, right? And so we had to toss out that answer. My answer is no solution, or it could look like the null set. All right, this is why I told you earlier that you needed to brush up on your factoring. So here's what we're doing. We need to figure out what the different things are in the bottom, but we have a lot of different things. The good news is that looks like it's factorable, right? it looks like since it has 3 terms, there's no GCF, it has 3 terms, we can use the star method to factor it. The top would be 15, the bottom would be 8, top left and top right are 1, and we're trying to think of numbers that multiply to 15 and add to 8, and I can tell you 9 times out of 10 that you're going to see those numbers in the problem somewhere, because they don't want to give you a bunch of factors, they want to give you just a few factors that match up. So 3 times 5 is 15, 3 plus 5 is 8. That means my 2 factors are y plus 3, y plus 5. I'm going to just get rid of this because I just wrote an equivalent version. The factored version is the same thing as what I started with. All right, now that I know my different factors are y plus 3 and y plus 5, I need to multiply by those on every fraction. Y plus 3, y plus 5. Everything that's separated by a plus, a minus, or an equals. And then I can eliminate the things that match up. So luckily in this first one, everything matches up. In the second one, the y plus 3's match up. In the last one, the y plus 5's match up. You know you're doing this right if you end up with no more fractions, right? You've eliminated everything out of the bottom. Here, I've got, again, a -2. You've got to be really careful with that negative sign distributed into that parentheses. I did not mean to write a equal sign here. All right, 6 minus 2y minus 10 equals, again, we have a -4 distributed into that parentheses. So that'd be -4y minus 12. Combine like terms, that would be -2y minus 4 equals -4y minus 12. Try and get all the variables to one side. And we get, I'm going to scoot over this way a little bit. So we get 2y minus 4 equals -12. Try and get the numbers to the other side. We get 2y equals -8. We divide by 2, and we get y equals -4. We didn't write down our restrictions. It's important to do that. But if I go back and look at what my restrictions are, y could not be -3, and y could not be -5. Those are the 2 things that would have made the bottom 0. Luckily, my answer does not match up with those, and so this is a valid solution. The next one is one where I do want you to try it on your own. Pause the video. This bottom left term seems like it's factorable. Since it's 3 terms, we will do star method, and it breaks down into x plus 4 and x plus 1. Luckily, those things look familiar, right? The things that we need to multiply on the top, since the only different things now are x plus 4 and x plus 1, we need to multiply by those things. We can eliminate everything that matches up, and then this is what your work will look like. You get x equals 1 as a solution, and from the beginning, x could not be -4 or -1. So the good news is we ended up with a solution, again, that is valid. All right, see y'all next week.